Algebra introduces the element of unknown. When we don't know what a number is yet, we use a symbol in its place. That symbol could be any letter of the alphabet. The most common letters usually chosen are X, Y, and Z. These letters are also known as variables. In algebra, we have variables or unknowns, and we are supposed to find their values. In arithmetic, we will leave a problem like this. 2 plus 3 is equal to blank. And then we write an answer after making the addition. But in case of algebra, we write the problem like this. 2 plus 3 is equal to x. The x here is the placeholder and stands for the number that we don't know yet. This problem could be presented in different ways of algebraic equations. 2 plus x is equal to 5 or x plus 3 is equal to 5. These are known as algebraic equations. An equation is a mathematical statement that two things are equal. This equation says that the known values on the left-hand side of this equation are equal to the unknown value on the right-hand side of the equation, which is being stated as x. The main goal in algebra is to figure out the values of the unknown represented by the alphabetical letters. Let's understand this further with the help of matchstick patterns. To make the alphabet L, we can take two matchsticks and place them like this. To make another L, we will need two more matchsticks to be placed like this. And to make yet another L, we need two more matchsticks. So a pattern is emerging now. If we have to find out how many matchsticks will be needed to make 20 L's, do we need to actually make 20 L's to find out? Won't it be too cumbersome? The matchstick pattern we made earlier has shown us that two matchsticks are needed to make one L. This can be represented as an equation such as number of matchsticks required is equal to 2 into number of L's. Let the number of L's be represented by the letter L. Now the equation becomes number of matchsticks required is equal to 2 into L or 2L. So for L is equal to 1, that is, if we want to make 1 L, the number of matchsticks required will be 2 into 1 is equal to 2. For L is equal to 20, that is, if we want to make 20 L's, the number of matchsticks required will be 2 into 20, which is 40. Now let's understand the term variable. In the equation, number of matchsticks required is equal to 2L. The letter L here is the variable. The term variable comes from the word change. The value of a variable is not fixed. It can have any value. In the equation, we have a number 2 which has a fixed value, but L does not have a fixed value. Its value can turn out to be any number. We are supposed to find the value for L. For example, as we made 20 L's, the value of variable L was 20. The equation will become 2 into 20, giving us the answer 40. If we were to make 15 L's, the variable L gets the value 15. So the equation will go like number of matchsticks required is equal to 2 into 15, and we get our answer as 30. In case we are making a C, the number of matchsticks required to make a C will be 3. So the equation will become 3 into number of C's, and then we will solve accordingly. We have actually been using variables in what we have already learned in mathematics. Let's begin with geometry. We learned how to find out the perimeter of a square. The formula to find out perimeter of a square is 4 into side. Now, if the given side of the square is s, then the formula becomes 4 into s. Now this s here is a variable, as the side of any square could be of any measure 6, 7 or 8 centimeter and so on. If we look at the formula for the perimeter of a rectangle, it is 2 into L plus B. Now these L and B are the length and breadth of the rectangle, and these are the variables here. Value of these variables will depend upon the given length and breadth of any rectangle. Similarly, all the formulas in geometry make use of variables. Let's now move on and see how we have been using variables in arithmetic. Let's begin with commutative property for addition or multiplication of numbers. Commuting means interchanging. The order of numbers in addition or multiplication does not change the result. 4 plus 3 will be equal to 3 plus 4, or 4 multiplied by 3 will be equal to 3 multiplied by 4. If we have to express this rule in a general term, we can write a plus b is equal to b plus a, and a into b is equal to b into a. Here, a and b are the variables, which indicate that a and b can have any values. The commutative property will be applicable to all the numbers. In the similar way, we have distributive property, in which we make the distribution of numbers in such a way that calculation becomes easy. For example, multiplying 9 with 103 could be very cumbersome. As per distributive property, 9 into 103 can be represented as 9 into 100 plus 3, which makes it easier to calculate. 9 multiplied by 100 is easy. It is 900. And 9 multiplied by 3 is also easy, which is 27. Now all we have to do is add 927, which is 927. Coming back to the formula of distributive property. As we have written 9 into 103 as 9 into 100 plus 3, it can be written as a into b plus c in general terms to represent any set of numbers. Now a, b and c here are the variables, as they can have any values. So this is how we have been using variables in geometry and arithmetic. When different terms are added, subtracted, multiplied or divided, the expressions are formed. If we write 5x minus 2y plus 7z plus 1, where different terms are being added or subtracted, we are forming an expression. Now, how an expression is formed? Let's have a look. If we write x plus 2, it means 2 is added to x, where x is a variable. If we write y minus 4, it means 4 is subtracted from y. Here, y is the variable. If we write 8z, it means 8 is multiplied by z, where z is a variable. If we write y upon 6, it means y is divided by 6 and y is a variable. If the expression is 3x plus 2, it means 3 is multiplied by x and then the product is added to 2. Here also, x is a variable. If the expression is 3y minus 2, it means that 3 is multiplied by y and then 2 is subtracted from the product. Here again, y is variable. There can be many more such examples of expressions. Now let's see how these expressions can help us in real life. Let's understand this with the help of a real life situation. You had a few cookies with you. A friend came over and took 5 of those. And then you had 7 cookies remaining. How many cookies did you have before your friend came over? Now this story can be made short and simple, which is easy to calculate. Assume you had X cookies with you. Your friend took 5 of those, so we subtract 5 from X. In the end, you were left with 7 cookies. So this entire thing, X minus 5, is equal to 7. Now all we have to do is find the value of X. We have converted this long question or situation into an expression and subsequently a small equation, which is X minus 5 is equal to 7. This can be easily solved for the value of X. So algebra makes life simple. Now let's shift our focus to the value of a variable. Before we move on, let's get the clarity on how an equation is different from an expression. If we write 2x plus 7, this is an expression. But if we add is equal to this expression, it becomes 2x plus 7 is equal to 11, which is an equation. An equation will have two sides, left-hand side and right-hand side, separated by an equals to sign. To find the value of a variable, let's use the equation 2x is equal to 8. Here, in 2x is equal to 8, we wish to find the value of x, so that left-hand side becomes equal to right-hand side. If we place the value of x as 1, then the equation becomes 2 into 1 is equal to 2. If we place the value of x as 2, the equation becomes 2 into 2 is equal to 4. If we place the value of x as 3, the equation becomes 2 into 3 is equal to 6. So, we still haven't found an appropriate value of x that can satisfy the condition 2x is equal to 8. So, let's carry on. If we place the value of x as 4, the equation becomes 2 into 4 is equal to 8. So now we know that if we place the value of x as 4, we will get the answer as 8. In any equation, a variable will have only one value. As we saw, the equation was satisfied by only one number, 4. None of the other numerals could balance the equation. The method that we just used to find out the value of x for the equation is called hit and trial method. As we use the numbers one by one to solve the equation till the time we did not find the right number. Now let us move on to the method of substitution to solve the equation. In this case, the value of a variable is given. For example, the equation is 5y is equal to 50 and the value of y is 10. Here we have to see if the value of the given variable y is correct or not. How would we know that? By substituting the given value with the variable in the equation. So after substituting y with 10, the equation 5y is equal to 50 becomes 5 into 10 is equal to 50. After solving, we see that 5 into 10 is equal to 50. It makes the left-hand side equal to right-hand side. Now let's see if the given value of y was any number other than 10, what would happen? Let the number be 5 this time. By substituting the value of y as 5, the equation becomes 5 into 5 is equal to 50. 5 multiplied by 5 is 25. So after solving, we see that left hand side is not equal to right hand side. So y is equal to 5 cannot be the right substitution.